Hello and welcome back. Our first stop in inferential statistics is in confidence intervals. And you'll see these all the time, all over the place, like in news articles or on news shows or whatever. So we can do confidence intervals for means or for proportions. We'll start with means. A confidence interval is a range of values in which we are fairly sure the true value lies. Now, unlike the weatherman in this Garfield comic, we want that range of values to be as small as possible. There are 4 steps to constructing confidence intervals. Step 1 is to find the point estimate. Step 2 is to determine the level of confidence. Step 3 is to calculate the margin of error. And step 4 is to construct the confidence interval. Of course, we'll start with step 1. Step 1 is to find the point estimate. A point estimate is a single value estimate for a population parameter. So let's just dive right into an example here. The following data was pulled from a survey asking how long, in minutes, people spend each day reading the news. So I put all this into a calculator, and I found that the mean of those numbers is 14.82. That's a sample mean. This is the point estimate for the mean time that people in general spend reading the news each day. Step 2 is to determine the level of confidence. Now, the level of confidence is the probability that the interval contains the actual population parameter. The level of confidence is often just given to you. And an example would be a 95% confidence interval says that 95% of the experiments will include the true mean, but 5% of all experiments will not include the true mean. Step 3 is to calculate the margin of error. Now, the margin of error is the greatest possible distance between the point estimate and the value of the parameter that it's estimating. And it's got this formula here, E equals Z sub C times standard deviation divided by the sample size. Okay, so standard deviation is on top here, and there's an asterisk here because if the population standard deviation is unknown, but our sample size is greater than 30, we can actually just use the sample standard deviation instead of the population standard deviation. So n is the sample size, and then there's this Z sub C. What is that? That's called Z values for the confidence level. So for confidence level 90%, our Z value is plus or minus 1.645. For a confidence level of 95%, our Z value is plus or minus 1.96. And for a confidence level of 99%, our Z value is plus or minus 2.58. If you forget these Z values, you can always figure them out again, and I'll show you how. So let's take a normal curve and let's look for the 90% confidence Z values. We'll mark the middle 90%, okay? And that means we've got another 5% at the bottom of the curve and another 5% at the top of the curve. So using your TI 83 or 84, you can use the inverse norm function of 0.05, and that gives you negative 1.645. So that's a negative 1.645, and we can mirror that positive value at the top. So that's an example of where those Z values come from, in case you forget what they are. So we'll bring up our data again, and we know that the sample mean is 14.82. We've got a sample size of 51, and using a calculator, I found the standard deviation of these numbers to be 8.96. Now again, even though the formula calls for the population standard deviation, we can use the sample standard deviation because our sample size is greater than 30. So if we want to find the margin of error for a 90% confidence interval, we put that into our formula. E equals plus or minus 1.645 times 8.96 divided by the square root of 51. Now plug all that in and you get plus or minus 2.06. So now we have all the information we need to construct the confidence interval. And that looks like this. We take the mean, x bar, subtract the margin of error, and then we take the mean and add the margin of error. So we'll take 14.82, subtract 2.06, 14.82, and add 2.06, which gives us 12.76 and 16.88. Now, what does that mean? What that means is that if we sampled 51 people over and over and over and over and over again, the true mean would be within a similar interval 90% of the time. But 10% of the samples would actually not have the true mean within the interval. So let's look at another example. The college admissions director at Pikes Peak University wishes to estimate the mean age of all students currently enrolled. In a random sample of 45 students, the mean age is found to be 23.1 years. Using past data, the college admissions director knows that the standard deviation is typically 1.7 years. Assuming the population is normally distributed, we're going to construct a 95% confidence interval of the population's mean age. So what do we know so far? We know that the mean is 23.1 in our sample. We have a sample size of 45, and because we used some past data, we know that the population standard deviation is usually 1.7 years. So we can plug all that into our margin of error formula, and let's pull up our z-values again. So if we're using a 95% confidence interval, then our z-values for this are going to be plus or minus 1.96. So you can plug all that into your calculator and you get a margin of error plus or minus 0.5. Okay, now that we have all that information, we can go ahead and construct the confidence interval. We'll take the mean, subtract the margin of error, and we'll take the mean and add the margin of error. So we have mu likely between 22.6 and 23.6. Now the good news, we can also use the calculator to find the confidence intervals. If you go to Stat Tests and go down to Z interval, highlight stats, and then plug in the information you know. The standard deviation, the mean, the sample size, and the confidence interval that you're looking for. And then it does all the calculations for you. So you can see here 22.603, 23.597. Now let's talk about finding the margin of error from a confidence interval. So given any confidence interval, you can actually sort of reverse engineer this whole process to find the margin of error. First thing you're going to do is find the average of the interval bounds. Then you're going to subtract the average from the upper bound. Let me show you. So here's a confidence interval of 4.87 and 6.91. First thing I'm going to do is find the average of the lower bound and the upper bound, and I get 5.89. So that's the mean. Now using the upper bound, I'll take the upper bound and subtract the mean, and that'll give me the margin of error. So 6.91 minus 5.89 equals 1.02, and that's the margin of error. Sometimes we need to know the smallest sample size we can use, because as you increase your sample size, your confidence interval narrows. So to find a minimum sample size to estimate mu at a given confidence interval, we can use this equation. Looks complicated, but it's not too bad. Let me just show you how it works. So you want to estimate the mean age at Pikes Peak University. How many students must be in the sample if you want to be 99% confident that the sample mean is within 0.75 years of the population mean? And we can use that standard deviation of 1.7 from the previous example. So we'll pull up our z-values again. And we want a minimum sample size for 99%. Okay, so we've got n equals that z-value, 2.58, times standard deviation of 1.7, divided by our margin of error of 0.75, Put all that into your calculator and square it, and you get 34.2. So we would need a minimum sample size of 35 to get a 99% confidence interval. Now, 34.2 usually rounds down to 34, but when you're finding a minimum sample size, you always round up. So that's confidence intervals for the mean. Just 4 simple steps to find a range of values. Next time, we're going to look at the mean again, but with small sample sizes. Thanks for being here.